Food is the most basic human need, a need that must be fulfilled every day to sustain life. Yet in our modern world that's full of scientific wonders and innovative technologies, mankind still hasn't been able to fulfill this basic need for our global civilization. In this video, we'll explore how nuclear science is helping end world hunger. From being used to increase food yields by eliminating pests, to research and technologies in nuclear medicine, which provide valuable tools for us to make sure that no one has to go hungry at night. According to the World Health Organization, there are around 820 million people worldwide that are food insecure. That's around 1/8 of the world's population. Just imagine, 1 out of every 8 people in the world is either hungry, malnourished, or doesn't have a reliable access to a steady food supply. This is the reason why eliminating hunger is one of the top global sustainable development goals set by the United Nations. The Sustainable Development Goals, or short for SDGs, are a collective 17 global goals that were established by the UN member states in the year 2015. These goals provide a framework to help drive countries toward improving prosperity of people and our planet. The 17 global goals are an immediate call to action by all countries across the world to ensure that our world is a better place now and for the future to come as well. Hey friends, my name is Osama Baig. I have a background in nuclear engineering, and on this channel, I help demystify nuclear technologies by simplifying them. I also like to go through these sustainable development goals and also show how nuclear science and technology can be paired with that of sustainability on a global perspective. While society has a preconceived notion that everything nuclear is bad, it couldn't be far from the truth. Scientists and farmers alike have been continuously developing new methods to both raise crop and livestock using developments in nuclear science and technology. Technologies that have not only been proven to alleviate food insecurity on a large scale, but also are very, very safe. For example, take radiation-induced plant breeding. This is where we use nuclear technologies to improve the seeds of plants even before they're planted. Now, I can understand that simply using the word radiation can start to trigger alarm bells for people that are listening. But it's important to note that radiation is not harmful. It can actually be used to breed plant varieties that are resilient, and then selecting plant variants based on likelihood of survival and them flourishing. Plants that are more resilient can undergo more stress as compared to other plant varieties. For example, they may be better at withstanding drought conditions or simply provide a higher level of nutritional value. And the best part is that these plants are completely safe to consume and also are free from any toxic pesticides. And that's just not me saying this. It's scientists from the World Health Organization, from the FDA, from the CDC, from the IAEA, the International Atomic Energy Agency, which have decades of experience researching these technologies and methods. Nuclear techniques have already been implemented in real-world applications for years now. In Indonesia, for example, more than 35 crop varieties were modified in order to increase crop yield. These crops, which include soybean and rice, produce more yield even in unfavorable climate conditions. And nuclear science doesn't just stop at the seed level. There's also many other techniques that farmers use even after plants have been planted and are starting to grow. For example, using isotope tracers in water and fertilizer, and then monitoring and diagnosing how plants efficiently use these resources while growing. Botanists use a naturally occurring radioisotope called phosphorus-31 to track nutrient changes within plants. Scientists use nuclear magnetic resonance alongside phosphorus-31 tracers, which are injected into plants. This helps them get a better view into the nutritional pathways within the plant itself. This method can provide really important insight into the plant itself. For example, scientists can better understand the plant in question and also understand whether it's losing water to that of evaporation or maybe something else. And if it is losing water to evaporation, where can they intervene to make the plant more water efficient? Isotope tracers are also popularly used in the world of medicine to both treat and diagnose patients effectively. These tracers are also used to study a wide range of tissues within the body, such as that of the heart, muscles, liver, kidneys, and other vital organs. So it's one thing to say that nuclear technologies can solve world hunger, and it's another thing to actually go and demonstrate that. So here are a few examples of how nuclear technologies are revolutionizing agriculture as we know it. Number one is improved soil and water balance. These techniques are being used across the world in many countries to help maintain healthy soils and water systems. Scientists use stable isotopes like hydrogen, carbon, oxygen, nitrogen, and sulfur to track contaminants that may have entered through the soil or water. Water and soil are two of the main ingredients which allow plants to grow. Any disruptions in those systems and crops start to die. And crops dying means instant famine-like conditions for many across the world, especially areas which people are already on the brink of starvation. An example of where these nuclear techniques were used was in a West African region called Benin. These methods were used to help around 5,000 farmers increase their maize yield by around 50%, and also with the use of 70% less fertilizer. The International Atomic Energy Agency Division of Nuclear Techniques in Food and Agriculture used fertilizer alongside the isotope nitrogen-15 in Benin. This method was used to effectively grow legume crops and also track the biological nitrogen fixation within the plant. Overall, this has led to considerable improvements in soil fertility. This means that farmers can use less fertilizers to meet the mineral demands of plants. Number 2 is pest management. Now, it isn't just about using less resources and increasing plant yield. Pest swarms like locusts are a real threat to any crop. In fact, a lot of famines that have taken place in the past have been caused because of major eradication of crops due to pest swarms, and these are natural phenomena. While traditional pesticides have been used on these crops for years in the past, they aren't always the safest or the most effective option. Nuclear-derived methods like SIT or sterile insect technique are effective means to control the pest problem in a safe way. SIT involves mass rearing and sterilizing insects before releasing them over infested areas. Think of it like insect birth control. It stops the exponential growth of these insects so that they don't become a threat to these crops. This method suppresses and then gradually eliminates pests that are a threat to crops in the region. The best part about it is that it is one of the safest pest control methods out there. The insects are made sterile through the SIT method, and other than that, insects don't carry anything on them that could negatively influence the crops. This is unlike chemical pesticides, which are absorbed by the plant and can have harmful effects on both humans and animals which consume these plants. Number 3 is food safety, and a really popular method that's used across the world is food irradiation. Food irradiation is used to increase the shelf life of foods by reducing or eliminating unhealthy microorganisms that exist on these foods. Initially, this technique was developed to increase the shelf life of food that astronauts took with them to outer space. Just like pasteurizing milk or canning fruits and vegetables, food irradiation can make food products much more safer for consumers. Food can be irradiated and in a safe way through sources of radiation like gamma radiation, which are found in radioactive isotopes like cobalt-60 and cesium-137. Fun fact, a large majority of the cobalt-60 that's produced in the world actually comes from a Canadian reactor design, a power reactor which produces these medical isotopes but also electricity. It's called a CANDU, so maybe you can check out some of my videos on that topic. And yes, for those of you who may be surprised, it is a very safe technique. The FDA has evaluated the safety of irradiating food for many decades, actually 30 years, and again it has said that irradiating food is safe. Other organizations like the World Health Organization and also the United States Department of Agriculture have also endorsed the safety of irradiating food through years of independent research. By increasing the shelf life of food, we can easily and safely transport food from areas that have a lot of abundance to those areas that really need it. This all comes without the fear of food becoming spoiled. Yes, worldwide hunger is as much a logistics problem as it is a production one. And irradiating food to increase shelf life is just one way in which we can make progress toward ending world hunger. Number 4 is livestock productivity. And what's interesting is that the benefits of nuclear science don't just apply to that of plants, but also extend to that of animals, especially when it comes to livestock productivity, and also prevent diseases like transboundary diseases between that of animals. A great example of this is how techniques were used in Cameroon to both increase and improve livestock reproduction, breeding, and pest control. The IAEA, alongside the government of Cameroon, used nuclear-derived procedures such as RIA, or short for radioimmunoassay, an enzyme-linked immunosorbent assay for both molecular diagnostics and genetic screening of cattle. Now, yes, RIA is definitely a mouthful. This allowed farmers to breed much more healthier cows, which in turn produce more milk. The result of this was cows producing 3 times the milk capacity that they once were able to in the past, tripling yield from around 500 liters to that of 1,500 liters of milk. Imagine the impact that this can have on malnourishment, especially on kids that are malnourished and simply don't get enough nutrients on a day-by-day basis. And affordable access to milk will help alleviate that. Number 5 is climate change adaptation and famine prevention. Even though underdeveloped countries across the world are not the driving force behind our current climate change disaster, it is a cruel irony that they are disproportionately affected by it the most. Climate change has caused water scarcity in the world in areas which were already facing water shortages. When there isn't enough water to drink, how can we expect them to grow their own food? One of the solutions nuclear technologies provide is breeding plants that use considerably less water and can survive in harsher conditions. Experts call these climate-proof crop varieties. Scientists looked at how rice and common bean plants react to extreme weather conditions. These are climate conditions which this particular variety of crops is not used to, and then they identified genes that are relevant to heat tolerance and also high yields. Once they had this information, they went on to develop breeds of plants with these desired traits. The result was rice and bean plants that can survive much harsher environmental pressures. Nuclear technologies have been deployed to help farmers adapt to climate change by reducing the resources needed for healthy crop growth. The nuclear-derived crossbreeding program in Burkina Faso is a great example of helping farmers breed more productive plants alongside climate-resistant animals. Solving world hunger is a multi-dimensional problem. It involves rethinking about almost everything from the way we grow our food to how we distribute it. World hunger is as much a logistical problem as it is a production one. So we need all the help we can get. Unfortunately, due to the negative connotations nuclear technologies carry, the benefits of nuclear technologies is often overshadowed. The negative perception of nuclear also means that more often than not, funding for such projects get cut, setting us back even further. If we are to successfully tackle such a complex problem in the world like world hunger, we need all the help we can get. And right now, nuclear technologies are the most promising ways we can do that. If you're interested in nuclear sustainability, I recommend checking out my other videos that I made on this topic, which is other UN Sustainable Development Goals and how nuclear science is relevant to these, which you can find up here. All right, thanks for watching. Take care. Bye.